What if we don't have a time interval? What if we're working without a time interval? We can still start with delta x equals 1/2 vi plus vf delta t. We can start with that basic equation, the first one we derived. We can get rid of that fraction. Rationalize the fraction. Multiply everything by 2. Remember, in algebra, you can do anything you want as long as you do it to both sides of the equation. So that gets us 2 delta x equals vi plus vf delta t. We can solve that for delta t. We now have an expression that we can plug into something else that uses displacement, initial and final velocity, and allows us to work without knowing our time interval. We have this expression that we just used for Vf in terms of Vi, time, and average velocity. What do you think is coming next? I sense a substitution coming up. See that delta t in there? Guess what's going to happen? We're going to shoehorn that expression that we just solved for delta t into there. I apologize for colorblind. I know it's run on a green screen. I need to change that. So I send my colorblind consultant. So we now have this expression for delta t shoved down into that other expression. We'll walk back through the derivations if you need to. We go ahead and do what we can to simplify that, rearrange. We're getting down to a point where we have, so suddenly you have a FOIL thing going. What we end up with is acceleration equals 2 delta x. Acceleration 2 delta times 2 delta x is equal to vf squared minus vi squared. We can rearrange to get an expression for final velocity that completely ignores the time interval. I know it's exciting. I know you're delighted and on the edge of your seats. We'll walk back through deriving this, I promise. Huh? That's the third golden equation that you've gotten? Or is that your fourth? That's your third. Oh, goody. You have one to go. Okay.